Good afternoon, guys. This is Professor David J. De Los Reyes, an electrical engineer by profession. Had been a professor of electrical engineering for how many years? Not so long years, but it's still considered long years. I've been a department head of the electrical engineering department in our College of Engineering, and had been an electronic troubleshooter when I arrived here in the USA, much more on the hands-on troubleshooting. My topic this afternoon will be lesson number 2 under the course Differential Equation. For those who are taking up engineering, this is for you guys. Okay, let's proceed. My lesson for this afternoon will be a new topic. This is a DE02. The title is Differential Equation. This is on the course Differential Equation. The subtopic is first order differential equation. First order. It will just be simply dy dx or dx dy. First order only. And the subtopic under first order differential equation, the first topic is there are so many classifications of first order differential equation. And one of the classifications is variable separable differential equation. So our main topic for this afternoon is the solution of a first order differential equation, subtopic variable separable. Meaning, after some algebraic manipulations, okay, the variables, the two variables involved on the equation will be separated, and we can now proceed with the integration. That's why the term variable separable. Okay, this is differential equation, guys. Don't worry. We've been saturated with problems on differential calculus, problems on integral calculus, application problems on differential calculus, application problem on integral calculus. Okay, so we are now on differential equation. There are some real problems being solved by the differential equation. One example of this is the water treatment plant. Okay, I've heard that the software they are using in the processing of the water treatment plant it involves differential equation. Okay, let's proceed. The given problem is this. Problem. We are given dy over dx equal to 2x minus 1. Okay. It says here when x equal to 0, y is equal to 1. What's the meaning of this one? The problem is asking for the solution y equal to a function of x. And since we are given an initial condition, the problem is asking for the particular solution. Okay? Particular solution under DE01, lesson number 1, previously. It should be the solution in which the constant of integration has a definite value. Okay? Why is that so? Because we are given an initial condition x equal to 0 and y equal to 1. So supposed to be we could solve for the value of the constant of integration. So what will come out should be a particular solution. Okay? Easy money, guys. We are saturated with problems on differentiation and integration, so this is an easy money when we reach differential equation. Okay. Let's try to bring out the solution. If you are on the board exams, show your solution as neat as this one, so the board of examiners will not be bored correcting your papers. If you can follow this is good for you guys. Okay, I will try to bring out the solution. Dy over dx equal to 2x minus 1. There are two variables, right? Y and x. Okay? For the meantime, this dy dx on the right hand side comprises of y and x. So, as a solution for this one, let's try to separate the variables, right? That's why our topic is variable separable. If we try to multiply all terms by dx, we are now separating the variables. Left hand side, this one cancels. What remains on the left will be dy. Right hand side, quantity 2x minus 1 times dx. We separate the variables. Okay? This is pure x, this is pure y. So we already have done the separation. That's why the topic variable separable. Don't worry, since the topic is variable separable, it's always to be separated easily, okay? You need some algebraic manipulations. So use your algebra. Then to solve for y as a function of x, bring out your knowledge of integration. The integral of the left hand side equal to the integral of the right hand side. Or the integral of the differential of y equal to the integral of the quantity 2x minus 1 times dx. We are now integrating. Right? Since we are now integrating, that's your problem. Bring out your knowledge of integration. Whatever type of integration that will come out, bring it out. Okay? The integral of the differential of y is just y equal to right hand side, okay? It's an easy money, guys. Constant in function. This is pure constant. So take that constant. This x here falls under the power formula. Should be x squared over 2. Easy money, right? Negative dx, the integral will be minus x plus c. Okay? These two here cancel with this. So y now will be equal to x squared minus x plus c. This is termed 2 as the so-called general solution. The problem is not asking for this one, but for sure we will pass by this to solve for the particular solution. So how could we bring out the particular solution? Applying the initial conditions. We are given the condition in the problem that when x equal to 0, y is equal to 1. So if we take the value x to be 0 and y equal to 1, we put it here. Okay? So 1 will be equal to 0 quantity square minus 0 plus c. 1, 0 square is just 0. Okay? Minus 0 plus c. These are now zeros. So c will be equal to 1. The constant of integration. So if we try to go back to the general solution, we could replace this c here by the value 1. Okay? So what will now come out will be y equal to x squared minus x plus 1, and this is now the particular solution. This is our answer. So I think it's a must that we should visualize our answer. How could we visualize our answer? Actually, our answer is an equation of a parabola that opens upward. Okay? When x is 0, y is 1. It is this. When x is 1, okay, this is 1 minus 1 plus 1, y is 1. When x is 1, y is 1. It is this point here. Okay? When x is 2, 2 squared is 4 minus 2, okay, is 2 plus 1, y is actually equal to 3. When x is 2, y is 3. 1, 2, 3. It is this point. Okay? When x is 3, just use point plotting. It doesn't matter, right? 3 squared is 9, minus 3 is 6, plus 1 is 7. So when x is 3, y is 7. 1, 2, 3. When x is 3 units, 1, 2, 3, y is 7. This is 1, 2, 3, 4, 5, 6, 7. Okay? At least we now know the curvature that will come out. So if we connect the 3 points, okay, this will come out. That is half of the equation. And supposed to be, if we assume values on the negative side, what will come out will be same as this one. So actually what will come out is actually a parabola that opens upward, and the vertex is actually at 0 and 1. That's the meaning of this. Okay? So the equation of this one is actually y equal to x squared minus x plus 1, a parabola. So our particular solution is actually a parabola that opens upward and the vertex is actually 0 and 1. That is how we work on differential equation. After bringing out the answer, try to take a graph so you could visualize what's happening. Okay? That's a variable separable differential equation, guys. Okay? It's easy. Okay? Good afternoon, Los Angeles. For those who are taking up engineering, this is for you guys. So if you want to subscribe to my channel, so you could study my topic under differential equation on my channel, this is for you guys. Please subscribe if you want a serious, what I call this, study of differential equation. For sure, I will give you a very detailed solution and very understandable in the very easy manner. Okay, good afternoon, Los Angeles.